Hello class, I'm Nicholas, and today we're going to be going through the Valgrind lab, and basically this is a software that you can use with your C programs to help detect like memory leaks. With this tool you can make sure you have your memory managed appropriately, and you can get rid of any concurrency and memory leaks, because this will give you some tools to check if what's even going on and how to fix them. So we'll get right into it. 20 years of Valgrind. So let me show you the guys. Let me show you guys the code. So for what we have loop count. This is like 1 million. This is a lot of disgusting loop. Then we got thread add here. So what this is gonna do, and we also have count. This is gonna take count and basically increment it for each loop count, and it's gonna keep going boom, 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 boom. And basically, once it gets the count going, we're gonna go into here where we have the P threads cooking, and we have 2 threads that's gonna be going for every single count, and it's gonna try to join boom, boom. It's gonna create them to try to join boom. If it doesn't work, it's gonna give us an error. If it does work, it's going to go in, and then at the end, it's going to show us the final count. So let me show you guys what happens when we try to run this. Oh, hold on, let me clear for you guys so it's like a lot nicer to see. So we do this, boom, the example, boom, we get segmentation core dump, because the memory just gets like exploded, right? So this is like kind of crazy, no? So from the Valgrind website, we can see literally everything here. We can get to exactly where we want. Table of contents, it has all the disgusting stuff. We can go in, but besides that, we're trying to work on this. I got the core dump done. Do man. This is for manual. Valgrind. You get the whole section in here, everything. Multiple pages. You can look through this when you need help. Okay, so what we're going to do first, we're going to check if there's a leak for memory. So we're going to first go, this is our first Valgrind command. Go in, leak, check.
Any memory, you'll notice it's going to run just a little bit slower because Valgrind is going on. And if we look at what's going on here, we get this report out here. Now in this particular case, we didn't have any problems with the execution. It actually passed the count. But what we see is at exit, we had 16 megabytes of memory that were being used by the program. We had some losses. So if we look here, it's telling us right now that in start thread, this thread add method, line 29, there is a definitely losing this amount of memory. If this program were to continue on and on and on, this would really be bad, and it might even result in the program crashing due to an out of memory condition. So I can use this to go in and look and see, okay, line 29, let's look at where line 29 is. Aha, I see a malloc right here. That malloc is mallocing the size of long.
So essentially this is the problem, because if the code were to keep running, then like there'd be a really bad memory incident going on. And we can see the places where issues are occurring, like malloc, start, thread add, all this stuff. So we're gonna go back to the code. We're gonna go to the malloc section. Can definitely begin to fix this. So we're gonna start by freeing the temp memory. See, we have the malloc over here, so we go down here, go free the temp, and this is gonna help us We're still gonna get an error though, so it's not gonna change much, but definitely get progress going. Yeah, we still get the core segmentation fault. So we still get an error, so there's still more work to be done. So, essentially this is a random event occurring where it keeps bugging. And this means because it's a multi-threaded thread code that, like, there's definitely a concurrency type of error, so we're going to be using the Valgrind tool. So we do this Valgrind tool. And it kind of works the same schematic as the other one, where it's going to give you the report and it's going to tell you where things are messed up. And we can clearly see process terminating with default action, error, thread error detector, Valgrind. It's going to tell you all this. It's basically the report right here. We can go in to fix it using this information. So basically what we're going to try right now is this part right here, this line and this line. And basically this is going to lock the mutex and then it's going to unlock it. And what this is going to do is going to make it run like less concurrency, so it goes in a more optimized way. So we're going to rerun the code after we compile and all that. It's going to give us the report again. It's taking a lot longer than it did last time. We get a much bigger report, so this is definitely a good sign. And basically it tells us there's a problem with the other part, these two parts right here. We can just quickly fix that by doing the same thing we did before, the unlock and relock. I'm going to try it again. It's going to give us the code again. And basically with those two lock statements and the unlock statements, we get the more consistent code and more like concurrent function. And it's going to give us this, and we will be done for today. Thank you everyone for watching.